So this is often what happens. Oh, I don't need this parenthesis here either, right? Yeah, that's cool. My parenthesis radar wasn't on, but now it's there. Okay, so I can copy this. I'm just working with the left side, right? So keep in mind that we're trying to work towards that right side up there. I'm not sure what happened there. Okay. So what? I can just get rid of this, right? Those things cancel out. I could write cosine squared as 1 minus sine squared again. Would that be helpful? Let's try it. I mean, maybe we're now parking down a dry riverbed, or whatever the metaphor is for that. That was a mixed metaphor. So this is I'm going to write sine here instead of, yeah. So I can say minus 1 minus sine, and then I need another parenthesis, right? So I'm simply doing it again, right? Replacing sine squared with 1 minus cosine. Oh, this time I'm replacing cosine squared with 1 minus sine squared. I don't see that helped, except maybe I can group the sine squareds now, and now I have 1 plus sine squared. Yeah, not really now. Okay, so you go back to the beginning and you say, well, well, I don't really see another way to go, right? Because I could think of this as a sum of squares, but then you can't factor a sum of squares, right? Does anybody see where I might have made a different move at some point and gotten a product? So here's something. So let's start out with here, okay? I'm going to copy this and go down a couple of pages and just paste it in. Okay, so for this first term here, okay, so I'm going to do it again, I guess. So we have this, right? So now for this first term, I'm going to say this is the square of 1 minus cosine squared. Okay, I guess I don't have the parentheses around the beta, but that's okay, isn't it? So I want the square of that, right? Is that agreeable? So what did I do? I said sine to the fourth is the square of sine squared, and sine squared is 1 minus cosine squared.
Okay.
Does that help? You can end up with the cosine to the fourth if I expand that. And then factor that out. I mean, you kind of want to look a step ahead maybe and see where you're going with this. Should I do the same thing with cosine to the fourth? Say that's the square of cosine squared. Replace cosine squared with 1 minus sine squared. We could do that. So for this term at the end, let me move this up. So for this, I can write sine. And change this to a squared, and then have a 1 minus that squared. Oh, what is it squared? Oh, well, I'm not. Oh, I see. This parenthesis. It's funny. It doesn't want to take that. So how about if I take this, and copy over this with that, and then just change this cosine to a sine, there. Right, you see what I did? So it's the same. Is this helping? No, no. Not so much, huh?
Would it help to just expand the cosine squared
Which?
at the last one, do cosine squared and then parentheses squared instead of just 1 minus sine squared. I don't know, kind of just throwing it out there.
I'm not quite following.
So the cosine to the fourth,
Yeah.
theta expands
Oh,
that
down,
out as
yeah.
cosine instead of turning it into sine. Because does it help to put another sine in there?
Yeah, maybe not. So what else would you do with cosine to the fourth?
I don't know.
That's not new.
Just expand out to
Yeah.
four.
All right, well, I'm gonna
I don't
call
know
this
if
a
it's
stumper,
helpful.
because I'm stumped. So, yeah, I'm gonna sign this for homework. Unless you see a different starting position, I mean, maybe at the very beginning, right? So actually, I kind of like that starting thing, right? So, but that got me to this, this expression, which is highlighted there now, the third one down, right? Which was kind of nice, because we were able to use the Pythagorean identity to get rid of that whole factor. But then how does that change into 1 minus 3? We gotta get 3 cosine squared sine squareds. I see one of them, right? So you'd like to get, yeah, 2 more? Okay, so going back, I mean, I said I was stumped, but it's hard to let go of these things. So if I expand that out, I'll have 1 minus twice cosine squared plus cosine to the fourth, which, yeah. Plus cosine to the fourth. Yeah. Okay, I'm stumped. All right.
What happens if you,
Yeah.
I honestly don't even know what I'm talking about, but what happens if you just expand out the second half, the second part, can you do anything with that? Like play around with?
This one?
No, the 1 minus 3 sine squared.
Oh, yeah, so instead of working from the left to the right, work from the right to the left.
Yeah, can you like make that anything else other than what it is?
Well, sure. I mean, you got these, so you could say this is 1 minus 3 times sine squared beta times 1 minus sine squared beta, right? And then distribute that, and you get 1 minus 3 sine squared beta plus 3 sine to the fourth beta. Maybe it's not even an identity. We should graph it and see. Did that help?
It was just an idea.
Yeah. So we could take, we got 3 of those things, right? We could take 1 or 2 of them away and change them into cosines. But yeah, let's try graphing just to be sure. Maybe they have us barking up a dry gulch, whatever the metaphor is. Down here I'm going to write sine of x to the 6th power. Right? And so notice what that looks like, first of all. It's not a sine curve, right? So why does it look like that, flat on the bottom? Well, first of all, yeah, it's got to be all positive outputs because it's an even power. And anything close to 0 raised to the 6th power makes it smaller, right? If you raise a small number to a large power, you get a very small number, right? So, but if you raise 1 to a large power, you just get 1, right? So everywhere where sine is 1, it's still 1, but where it drops off faster and stays smaller for longer. Okay, so we want to add to that cosine of x to the 6th power. Okay, we get that. That kind of looks like a sinusoid, doesn't it? Wow. to say, huh? What would the amplitude be? Well, a little less than a half, the line of equilibrium, it's just like to be a cosine curve or something, that's hard to say. Okay, then what about the right-hand side? Well, that's 1 minus 3 times the square of sine beta, or sine x here, am I right? So sine of x squared times cosine of
That works, no?
x. I guess I need to square that as well, right? I don't know, maybe you can put the square in now. Okay, so that's going to be P1. And so I can say, give me P1 x minus shift. And you can see, yeah, sure enough, these are the same function. But how you prove that?